Hello everybody, in this video we are going to solve one electrical network in which we are asked to determine the currents I1 to I5. This is problem number 2.31 from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. Okay, let's get started. So first we should know what is the procedure for solving this problem to determine the currents. Okay, now look at the circuit. This circuit consists of this 200 volts DC supply, and then here we have the major current I1. This can be taken as I total, and then this is being divided into two currents further as I2 and I3 for these branches. So this I3 current is further dividing into two more currents as I4 and I5. So for this we need to follow certain steps or procedure in order to find out the currents. Okay, in this procedure the first step is to find the R equivalent of the whole electrical circuit, and the second step is to find the total current, that is I total, using Ohm's law, and the third step is to find the individual currents using current division rule. So we need to know how to find out this R equivalent first. So in this, the resistances of the branches can be calculated as a total resistance or a equivalent resistance by combining them in two forms. One is they can be combined as a series resistors, or they can be combined as parallel resistors. If they are series resistors, just the sum of them is giving you the R equivalent. So you can look at this. Here we have this, yes, so you need to find out the sum. And if you have the parallel resistance, I'm talking about only two resistances here. Okay, so if you have two number of parallel resistance, and then we need to find out the product of that two resistances divided by the sum of the resistances. Product of that resistance divided by sum. Here if it is P, here also you have the P. So in that way you can recollect if you want. Okay, I want to make it easy for you. We are going to follow the first step now. So to find the R equivalent of the whole electrical circuit, so we need to start from here, these two branches. So how to find out the equivalent? Here we have this 1 ohm resistance at this branch, and here we have the 2 ohm resistance. So the R equivalent 1, okay, for this branch is 1 into 2, that is the product of the two resistances on the branches divided by the sum, isn't it? 1 plus 2. So this is equal to 2 by 3. Then we need to modify the circuit with the equivalent resistance, so that you will be getting this circuit as this supply 200 volts, then here you have this 3 ohm resistance, then here you have the branching, so that on this side you have this 4 ohm resistance, and here we have found out the equivalent resistance, that is equal to 2 by 3 ohms, and then it is closed like this. Now for these two resistances of this branch, we need to find out the equivalent. So we name it as R equivalent 2. So that is equal to the product of these two values, 4 into 2 by 3 divided by 4 plus 2 by 3. So this is equal to 8 by 3 divided by this 3. Then here you have this as 12 plus 2, isn't it? That is 14. These two get cancelled, so we get this as 8 by 14, 4 by 7. Okay, this much more. Okay, once you find out this equivalent resistance, once again you need to redraw the circuit. Okay, so we come from here like this. This is a modified circuit. So here we have this plus minus, that is 200 volts. Then here you have this 3 ohm resistance. Then this equivalent resistance R equivalent 2. Okay, this is R equivalent 2. That is equal to how much? 4 by 7. So this circuit is now redrawn like this. So for this, finally we need to find out the R equivalent of this whole circuit. That is equal to, here if you see these two resistances are in series. They are in series. Okay. So it is 3 plus. So we need to find out the sum. 4 by 7. So how much it is? 7 21 plus 4. So that is equal to 25 by 7, isn't it? So this much more. So now this circuit can be again redrawn. It is 200 plus minus, that means it is 200 ohms. Then here you have this R equivalent. So what is the R equivalent value here? It is equal to 25 by 7 ohms. So the first step is over, isn't it? We have found out the R equivalent for the circuit as 25 by 7 ohms. What's the second step? So now we move on to the second step. Second step is to find the total current I total using Ohm's law. So for that we have to use this particular equivalent circuit only. This is the equivalent circuit we got, right? So from this circuit only we can move on to the second step, that is to find I total. So how to find out this I total? That is nothing but Ohm's law, isn't it? By using Ohm's law. So I total is equal to, I is equal to V by R, isn't it? V by R equivalent here. So what is the V value here? That is 200 volts divided by R equivalent is 25 divided by 7. So that is equal to 200 divided by 25 into 7, isn't it? So it is 8 times 7. So it is 56 amps. So we found the I total. I total is equal to 56 amps. Now we have to go for the third step. What is the third step? It is to find out the individual currents using current division rule. Okay. So what is the current, total current I total that is flowing here in this path, that is equal to 56 amps. Okay, I total is 56 amps. So you now come to this circuit. We are again traveling in the forward direction. Okay. So this current we identified as 56 amps. This is our I total. So the same current will be flowing through this also. This current is taken as I1 current. So we got the answer for I1 in this. Okay. So what's the answer for I1 here? This is one answer. First answer we got. This is our I total. That means 56 amps. This is one answer we got. The same current I1 will be flowing through this path also, but this is an equivalent circuit. So the I total or the I1 which is flowing through this circuit, which is the equivalent circuit. Now we move on to this again. So this is your I total or I1 is equal to 56. That will be divided into two currents like this. This current is named as I2 and this current is named as I3 in our problem. You can refer this. This is I2 which is flowing through this 4 ohm resistance and the remaining branch currents, that is I3. So for this, how to find out this I2 and I3? So for that case, so we use the current division rule for that. So what is that current division rule? So current through a particular branch. That means if I want to find out this I2 current, that can be found out as the total current, the I total or I1 current multiplied by resistance of the other branch. So I find out this current I2 means resistance of the other branch is taken as 2 by 3. So other branch resistance divided by the total resistance. Okay, that means this 4 plus 2 by 3. Understood? This is the current division rule. So what is this I2 now? I2 is equal to I1 is 56 into 2 by 3 divided by 4 plus 2 by 3. If you take common denominator, it is 12 plus 2, that is 14, isn't it? So this 3 get cancelled. You can cancel out this also. So this is 8. I2 is equal to 8 amps. So this is our second answer. We found out the second current. So after finding the second current, you can find out this I3 current also. The same rule or current division rule is applicable here also. So how to find it out I3? So this I3 is equal to total current or I1 current 56 multiplied by the resistance of the other branch. So other branch resistance is this 4 ohms, isn't it? Because we have these two resistances here. This one branch resistance, this is another branch resistance, isn't it? So if you want to find out the current for this branch, then you have to refer this total current 56 which is being divided into this I2 and I3, isn't it? So 56 into the other branch resistance divided by total resistance. Total resistance is 4 plus 2 by 3 again. So this answer can be like 56 into 4 divided by this 3 is common, so it is 14. So 4 times it goes, isn't it? So that it is equal to 16 into 3. So that is equal to 48 amps. This is one way of calculating this branch current. Otherwise, simply you can substitute, because here 56 amps current is coming, and here we already found out the I2 current is 8 amps. That means the remaining will be flowing. That's it. So it is 48 amps. Simply you can subtract this 8 amps from this 56 amps, so that you will be getting this 46 amps very easily. Okay, so what's the answer for this I3? So this I3 is equal to 56 minus 8 amps, or using current division rule, which is found to be 48 amps. So we got the third answer. Now we move on to this picture, main network. Okay, here again, if you look at this we have I3, which is 48 amps, that is further divided into two currents as this I4 current and the I5 current. So first you can use this current divider rule or current division rule to find out this I4. So what is this I4? I4 is equal to total current. The total current here is I3. You should know that. Okay, this I3 is divided into I4 and I5. So total current for this case is I3. So I4 current can be found out as total current multiplied by resistance of the other branch. Here the other branch resistance is this 2 ohm resistance divided by the total resistance. That means 1 plus 2. Okay, so what it is? It is 48 into 2 divided by 3. So if you divide this, it is 32 amps. So I4 is 32 amps. This is another answer we got. If I3 is 48 and this I3 is 48 and the I4 is 32. So what is I5? I5 is equal to this I3 minus this I4, isn't it? Because this is the total current here. This I3 is equal to 48 amps. So here we found it to be 32 amps. This I4. So the remaining will be flowing here, isn't it? So it is 16 amps. It is equal to 48 minus this 32. It is equal to 16 amps. So we got all the currents now. So what is I1 now? So we'll summarize the answers. So I1 is equal to 56 amps. I2 is equal to 8 amps. So that this I3 is equal to 48 amps. I3 equal to 48 amps. And I4 is equal to 32 amps. And this I5 is equal to 16 amps. So we got all the answers. Thank you. Hope you have understood.